What you can see here is a RAG evaluation tool my team created to monitor and evaluate the answers that our RAG solution is returning to customers. The premise of this little sample is that our company has an online seed catalog, and our customers come to the website to order seeds and garden supplies. And on our website, we have a RAG solution that can answer questions. So customers will type in their questions. The RAG solution will answer their questions based on articles on the website. And this is the tool we use to monitor and evaluate the answers that are returned. So you can see the user question comes in on the left. The answer that was generated by the RAG solution is shown in the middle. And on the right-hand side, there are criteria that we can manually click to evaluate how well that answer addresses the user's question. There's a filters menu. So if there are too many piling up, we can say only show question answer pairs starting on this first day and ending on this final day. We can also hide or show only those question answer pairs that have been evaluated or not. And if there are so many question answer pairs that it feels a bit overwhelming, you might choose to only see a random subsample. So that's the premise. That's what we're starting with. Now let's imagine that my team wants to make our evaluation task even easier by adding some natural language interface features to our RAG evaluation tool. So let's open up the natural language interfaces prototyping tool. Let's try asking some questions. What filters are there? And you can see we got the answer back, date range, and evaluation status. Okay, that's not bad. Let's see how that answer got generated. I can look in the logs and I can see some highlights. I can see what the user input was. I can see it was classified as a question. We can see that the question is most closely related to the filter icon div element in the user interface. And then you can see the help that was generated. Let's click on the details to see what was happening under the covers. First, a large language model was used to classify the user input. You can see the prompt is classify the following user input into one of question, action request, or none. And then you can see each of those classes is defined. Then you can see the user input is pasted in there. And you can see the generated output is the class name question. What happens next is a large language model is prompted to identify which element in the user interface is most closely related to the user's question. It says a web interface has the following elements, and then there's like a list. There's the element and the description of the element, and an element and the description of the element, and it goes on and on and on till we cover all of the elements in the interface. Then the prompt says which element is the following user message about. We paste in the user input. And then the generated output is the ID of the element that the large language model thinks is most related to the user input. Now, the third prompt is asking a large language model to answer the user question based on some given information. You can see in the prompt, it says article : and then there's some text there about the open filter menu element. And then the prompt says, answer the following question using only information from the article. Then the user question comes in, and then the generated output says date range and evaluation status. So we used 3 prompts. We classified the input as a question. We identified which element of the user interface the question is most closely related to, and then we generated an answer to the question based on information about that user interface element. Let's keep digging to see where did all that stuff come from. Well, first of all, there were the 3 prompts. So if I go up here to the prompts section of my prototyping tool, I can see there is the classify input prompt. And you can see this should look familiar. This is what we saw a minute ago. Classify the following user input into one of question, action request, or none, and so on. Then you can see there's a placeholder for the user input. At runtime, we paste in what the user input was. Now let's look at the prompt for identifying the element in the UI that is most closely related to the question. This one should look familiar again. It starts with a web interface has the following elements, and then there's a placeholder where we're going to paste that list of elements. We'll see where that comes from in just a second. And then there's the prompt, which element is the following user message about, and then we paste in the user input. You can see that little placeholder there. That's the second prompt. And then the third prompt is the question answering prompt. Article : and then there are some placeholders there again for information about the related user interface element. Then there's the rest of the prompt saying answer the following question. Then there's a placeholder for the user input, and then we generate the answer. So those are the 3 prompts that were used. But let's look at where is the information about the user interface elements coming from. That's coming from the element details JSON structure that you can see here. So this is an array, and each element in the array has information about one element in the user interface. So the first one is the Open Filters menu button. So that was the little funnel-shaped icon that I clicked originally to open the filters menu. And you can see the DOM ID, that refers to the ID in the JavaScript in the user interface. Task description is a little sentence or a couple of sentences saying, what do you do with this user interface element? The actions array says what should happen if that element is triggered through the natural language interface. And then there's an article array. In real life, probably this article array could point to product documentation or blog posts or something like that. But for now, these are hard-coded here in a list, and they're just little strings with information about that user interface element. And you can see we've got the same for all of the user interface elements in our RAG evaluation tool. There's the close filter menu button. There's the first date filter input and the final date filter input. And there are those checkboxes for showing the evaluated answers or showing the unevaluated answers. And then there's that random sample input text box. The reload button is what you would click or maybe use the natural language interface to activate. The reload button is what applies the filters and causes the number of question answer pairs that you see there to change. So we had prompts with placeholders in them, and in those placeholders we can paste text from this element details structure, and we can paste the user input. That's how we come up with those prompts we saw in the logs at runtime. So what happens if we discover that an answer returned by the solution is not very good? What can we do about that? This is a prototyping tool after all. So let me try a different question. How can I filter these? The answer I get says, clicking this opens the filters menu. That's very vague. The word this is not helpful. We need to figure out where did this kind of bad answer come from and then do something to fix it so it has a better answer. So let's look in the logs to see the question answering prompt. And you can see there, oh yeah, clicking this opens the filters menu is actually part of the element details information that was pasted in as the quote unquote article text. So let's go look at the element details JSON structure and find the Open Filters menu button part of it and see if we can improve some of the strings there to change what the large language model generates. Where it says clicking this opens the filter menu, let's change the word this to the filter menu button. Okay, now I'm going to click save. Let's ask the question again. Aha, making a change to the element details information changed the prompt a little bit, and as a result, the large language model went down a slightly different path and generated different output. I'd say that answer's better. And you could play around with it if you want answers to be longer or more thorough or whatever. You could go up and change the element details information as much as you like. So that's question answering natural language interface features. What about actually interacting with the UI using a natural language interface? Let's try that now. I'm going to say, let's see a random subsample of 5. Okay, and I can see on the left-hand side there, the random sample size input field now has the number 5 in it. And if I wanted to actually apply that filter, I could click the reload button, or I could use the natural language interface to cause the reload button to be activated. Like I could say, reload the page. So let's look and see how did that number 5 get put into that input field. Back to the logs. Here we can see the classification again. This time, the user input has been classified as an action request. Then let's look at the prompt that figures out which element in the UI is most closely related to the user input. Same thing again, a web interface with the following elements, and then there's a big long list there. And then at the bottom, the end of the prompt says which element is the following user input about, and then the user input. And this time, the large language model has generated the output sample size input, the DOM ID of the random sample input field. So far, so good. It's the second prompt. The next prompt is different because we're not answering a question. In this case, what we do is we take the same prompt we just had and we append more to the prompt and we submit it again. So here's the same prompt again, which element is the following input about, and then we paste in the generated output, and now we add some stuff to the bottom. What value should the element be set to? And then there's a little bit of some extra information telling the large language model about the format that we want the answer to be in. And now the generated output is 5. That's what we wanted. So let's look at the prompt. We didn't look at that prompt before. The prompt for identifying values. In this case, the prompt was appended to the previous prompt and then resubmitted. So this is what got pasted on the end. What values should the element be set to? And then there's extra little information about formatting, and that's the prompt. So that's how we can interact with the UI. Previously, we classified the input, we figured out what element the input was related to, and then we did a question answering prompt. But this time we classified the user input, we figured out what element is related to the user input, and then we had to figure out if there was a value in the user input that needs to be applied to the element. So let's see what happens when things go wrong. This is a prototyping tool after all. So I'm going to put the input, hide everything after the end of January. Okay, so we can see that the final day date input has been updated. That's good. It's the right element to update. And end of January, that part is correct, but the year is wrong. Currently, at the time of this video, the year is 2024. So if I don't say a year, then I just mean this year. So we're going to have to update that value prompt to help the large language model know that. So let's go up to the prompt, and in the notes about dates, let's add a little extra qualifier saying if no year is given, just assume the current year. And I'm going to save that prompt, and I'm going to submit the same thing again. Hide everything after the end of January. Now, even though I didn't say 2024, the assumption is if I don't say a year, it should be the current year. And that correct value is now in the final day input field. This prototyping tool makes it quick and easy to change prompts and element details, and then experiment by submitting input and looking at the logs to see how the prompts are put together and the output that is generated at each step.